Hi, I'm Beth Wilson, and I'm here today with Ken Hyde. How are you, Ken?
I'm well, thank you.
And we are at your workshop, The Wright Experience, and I was wondering what the Wright Experience does and what fascinates you about the Wright brothers.
Well, we're inspired by the Wright brothers, just the simple fact that they were so secretive about their work and how they were able to use just simple math to develop the airplane when no one else could do that. So that's our job, is to figure out what they were thinking and how they were building airplanes.
And you build these airplanes, correct?
We do. We build the aircraft and we reverse engineer them. We have aerodynamists look at them. We put them in wind tunnels. We flight test them and get as much data as we possibly can.
And are you all fearless enough to fly these things?
Oh yes, the airplanes need to be flown to really have the full joy of the work that we do. So the 1902 glider and the Wright Model B are all airplanes that we've flown, plus the 1903 Kitty Hawk Flyer.
This is STEM in 30. Hi, I'm Beth Wilson, and I'm coming to you live from the Wright Brothers Gallery at the National Air and Space Museum. And today we are talking about this airplane. Does anyone know what this airplane is? Any guesses? Okay, well, this is the very first airplane. This is the built by the Wright brothers. It was the first successful airplane to ever fly, and today is the 100th and 11th anniversary of that flight, and that's why we're talking to you today. So what we're going to do is I'm going to ask you all, my students here from Blow Pierce, what do you need to fly? What do you need? Wings. You need wings. And here on my desk, I know it's a little hard for you all to see it, but I have a wing, and you can tell it's a wing shape because it's fat at this end and then it tapers and it gets thinner at this end. But just as important as this shape is this shape, okay? Now I know this is a little hard to see, so I've got a larger one. So what we've done is we've essentially taken an airplane wing and sliced it up so that you could see this section. This is called an airfoil. Now an airfoil is curved on the top and it's flat on the bottom. And the way an airfoil works is had wings, okay, I would be going down the runway and the air would hit the leading edge or this front part of the airfoil, and some of the air would go over the top and some of it would go under the bottom. Now the air on the top starts moving more quickly, and this faster moving air creates a lower pressure. So there's less air pushing on the top, but there's greater pressure up underneath, and these two try and equal out, and that's what lifts a wing or an airplane into the air. Now I know this is hard for you to understand by me just telling you. So you all here in the museum have a piece of paper, right? So I want you all to pinch either end of your piece of paper, and we're going to put this on our top lip, and we're going to blow. But before we blow, which way is the paper going to go? Is it going to go up or is it going to go down? Up. All right, let's try. Right, so the paper goes up simply because you are pushing, your breath is pushing the paper up into the air. Now, we're going to do the same thing, but we're going to put the paper on our lower lip right here. And we're going to blow, but before we blow, which way is the paper going to go? Is it going to go up or is it going to go down? Down, let's try. 1, 2, 3. Which way did the paper go? Up. And it went up because you had faster moving air over this top surface that created a lower pressure, and that lifted the paper into the air. Now the Wright brothers knew that in order to make a good wing, you'd have to have a good airfoil shape. And they tested those airfoil shapes in a wind tunnel. And right here we have Tom Crouch, senior curator, and Paul Glenshaw, and they're going to talk to us a little bit about the Wright wind tunnel.
Thank Beth. Well, this, as Beth said, is the Wright wind tunnel. Not the real one, but it's an exact replica of it. And it's pretty simple. It's just a wooden box down here, and there's a fan inside this metal housing. So the fan moves air through the wooden box. But the neat part is what's inside the tunnel. This thing is called a balance, and it's what the Wright brothers used to get the data on their airfoils. The balance is just a thing. You put little model wings, just like this one. You can see that this one has cambers curved, just like Beth's wing was. And so when you turn the wind tunnel on, the little wing reacts just the way a wing does in the real air. So Paul, you want to show us what happens here?
Thanks, Tom. Yeah, what I'm going to do, what the balance does, is very similar to what you might do if you put your hand outside a car window while it's moving. If you put your hand out just like this, it's going to blow straight back. That's called drag. But if you turn your hand a little bit so it's like this, your hand's going to go up. You're going to get faster moving air on the front, slower air on the bottom, and you're going to get that lift effect. And so what the Wright brothers did is they created a little balance where on the bottom we just have little metal fingers that only make drag, and they turn the balance one way, and we have the wing which wants to turn the balance the other way. So what I'm going to do is turn the tunnel on, and I'm going to block the air off to the wing. So we'll see the drag turn it one way, and then I'll pull it away. The wind will hit the airfoil, and it'll actually create lift. So we'll look at it up here in the mirror. So when I block it off, balance rotates, the drag is pulling the balance that way, and when I pull it away, the wing rotates it that way. So that's drag, and that's lift.
So it's operating in the wind tunnel, just the little model wing, just the way a real wing does in the air.
And what the Wright brothers did is they started playing with the shape of the wing. They had some that were square, some that were long, and they measured them all exactly the same way, and they started to see that long, skinny wings were going to work much better than short, stubby wings, which is what they had been using.
Thanks, Paul. Thanks, Tom. And we have an online question. Tom, can you tell us how big was the Wright brothers airplane?
Well, you can see it right back here. This is the real Wright brothers airplane. And so you can see roughly what size it is. There's Wilbur Orville, rather, laying there on the airplane. So there it is.
Okay, and we have a question in the audience.
My name is John Cash Waters, and I want to know, why did they think of building it? Why did they want to build an airplane?
Why did they want to build an airplane? Tom, can you tell us why did they want to build an airplane?
Well, a lot of people, when they were working right at the beginning of the 20th century, a lot of people were interested in the invention of the flying machine. Flying is something people had dreamed about for a long, long, long time. And bit by bit, pieces had fallen into place. And so there was a sense, Wilbur and Orville had it, and other people did too, that the time was ripe. A lot of pieces were in place, and this was the time to really attack the flying machine problem. And Wilbur and Orville had been interested in flight since they were your age. So they thought about this a lot.
Okay, and we have another online question. And the question is, what was the Wrights' very first invention?
Well, the Wright brothers didn't start with the airplane. Their first business that they did together was to run a print shop. They printed little neighborhood newspapers and other things, shopping flyers and that kind of thing. And Orville actually built a very different kind of printing press that just really impressed printers all over Dayton, their hometown. When they were operating their bicycle shop, they invented a special bicycle wheel hub as well. So, I mean, they were inventive, creative guys, and that was happening before they turned their attention to the flying machine.
Okay, and speaking of bicycles, you all can see I have a bike on my table. Why do you think I would have a bicycle on this table? Why is this bike here? A, the safety bike became popular in the late 1880s. B, there are bicycle parts on the 1903 Flyer. C, the Wright brothers built bicycles before they built airplanes, or D, all of the above? Okay, so if you said D, you were correct. It was all of the above. And to explain a little bit more about how bicycles and airplanes are related, I spoke to our chief curator, Peter Jacob, and he's going to talk to us a little bit about it. You're chief curator of the museum. Why are you riding a bicycle in the museum?
Because a bicycle is a wonderful way to show something really important about how the Wright brothers invented the airplane.
And what was that?
Well, an airplane, of course, has to be controlled. If you can't control the airplane, you're not going to be very successful in the air. And an airplane is very similar to a bicycle in that an airplane, although it's very unstable, is very controllable, just like a bicycle. Now, if you look at a bicycle, if you let it go, look at that. It falls over. It's totally unstable. But when you're riding it, by turning the wheel and leaning in and out, you can make it very controllable. And the Wright brothers took that idea and transferred it to the airplane. Now, before the Wright brothers got involved with airplanes, they were bicycle manufacturers. In fact, we have one of their original bicycles right here in the case.
So are there any other connections between bicycles and the first airplane?
Yeah, being very familiar with bicycle technology, the Wright brothers were able to transfer some of those ideas to the airplane. In addition to the control, if you look very carefully on the bicycle, you see the way the pedals and the wheels are connected is with a chain and sprocket transmission system. So when you turn the pedals, you see the wheel turns. If you look at the airplane, you see they use the same technology to connect the propellers to the engine.
Oh, that's great. Okay, but no more riding in the museum, all right?
Okay, as long as we get the ideas across, I'll stop riding.
Thank you. Okay, so as Peter mentioned, you have to be able to control an airplane once you get it off the ground. And the first way to control an airplane is pitch. It's this up and down motion. And this is controlled by the elevator in the front. An easy way to remember that is an elevator in a building only goes up and down, and the elevator in the front of a plane controls the pitch. The second way to control a plane is yaw. It's this motion. This helps stabilize the plane, and it's controlled back here with the rudder. The third and final way to control a plane is roll. And roll allows you to turn a plane while it's in flight. So those are the three ways that you are able to control a plane once you get it off the ground. So let's have you all stand up, and anybody else watching, stand up. Put your arms to your side. Do not hit the person next to you. We're going to practice roll, pitch, and yaw. So let's start with pitch. Ready? Let's pitch. Okay? Now we're going to yaw, 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 and now we're going to roll. Roll, roll, roll. Okay, I think you guys have got it. Good job. Go ahead and sit down. One of the challenges that the Wright brothers had was to try and figure out how to make an airplane roll. There were a lot of people working on inventing the airplane at the same time that the Wright brothers were, and they were all trying to figure this problem out. Well, the older of the two brothers, Wilbur, had sold an inner tube at the bicycle shop, and he was playing with the bike, and he was playing with the box, and he was bending the box like this. And he thought to himself, gee, you know, if I can get to change shape like this, I can get it to roll, because what's happening is on this end, when this side goes up, there's greater lift, so that side will go up and this side will go down. And if I switch it it'll go the other way. So I could get a plane to roll if I can change the shape of the wings. Now, he didn't go out and just invent the airplane. He had to do some experiments, and one of their first experiments was their kite. And Tom Crouch is going to discuss the kite with us today.
Thanks, Beth. Indeed, what we have right here is a full-scale model of the very first aircraft the Wright brothers built, and it was a kite. And as Beth explained, they began by figuring out how to control an airplane in the air in roll, pitch, and yaw. And the tough one was roll. And having come up with the notion of twisting the wings, changing the geometry of the wings, they wanted to test that idea. And they built this little kite. It's got about a 5-foot wingspan, and these things down here are the kite sticks. It has 2 lines, so you actually fly it by holding the sticks like this, and the kite's up there. If you move your thumbs forward like that, what'll happen is the bottom wing will move forward, or backward rather, and the top wing will move backward, the bottom wing moves forward. And just the opposite if you put your thumbs the other way. But the neat thing is, if you oppose your thumbs like this, what happens is that you put a twist, a torsion, across the wing. And if you look at this wing, this is angled up more than that is, right? So which side's going to have the most lift, do you think? This side or that side? This side, absolutely, because you've not only increased the angle, but the lift. And you can do just the same thing on the other side. And so this is how the Wright brothers, by maneuvering their kite, discovered how to control an airplane and roll.
And so as we have to be able to control the airplane, but they didn't use strings on the airplane, did they?
They didn't.
No, they didn't. So we went to the Wright Experience, and we have a video showing you actually how the wings change shape. So let's take a look.
And how they're controlled.
And how the plane's
So
controlled.
we've been looking at the 1903 Wright Flyer that we have in the museum. But here at the Wright Experience, they have VinFizz. Do you want to tell us a little bit about this airplane and show us how the wings warp?
Sure. Well, this airplane, built here at the Wright Experience, is an exact replica, as close as you can come, to the original VinFizz, which is on exhibit in the Pioneers Gallery in our museum. This really is incredibly accurate. And of course, it's the airplane that Cal Rogers did make the first coast-to-coast flight with a good many stops, not all of them intended or pleasant, in fact. It's a Wright Model EX, it's called, and it's a fairly typical control system for Wright airplanes of this period. Of course, from 1900 to 1905, they were laying down on the airplane, so they had different controls. When they went to upright seating to carry a passenger, they had to have upright controls. And again, these are typical of Wright controls for this period. And this stick is the stick that warps the wings. You go back, and you can see the wings warp, and forward, back, and forward. And this is what we call the bent wrist control. This is the control that feeds rudder into the system. And that control is the pitch control that controls the elevator in the back of the airplane.
Well, thank you very much, Tom. That's really interesting.
So Tom, we have an online question. How did the Wrights fly?
How high did the Wrights fly? Well, in the beginning, with this airplane in 1903, really not very high, probably never more than 20 feet or so off the ground. But as they continued to practice and develop the airplane, by 1905, they'd been practicing for 2 years, and then they could fly basically as high as they wanted to and stay up as long as they wanted to.
Okay, and I think we have one question from the audience. What's your question?
My name is Mikhail, and my question is, what inspired the Wayne Bros?
Oh, what inspired the Wright brothers?
Well, as I said, a lot of people wanted to fly at the time the Wright brothers became involved. They weren't the only ones. Lots of people did. And the Wright brothers were really fascinated by problem solving difficult technical problems. That's really what made them get up in the morning and why they pushed forward with this. They really enjoyed that problem solving, and really that's what inspired them. Once they got started, they just couldn't let go until they had solved all the problems and were ready to fly.
Okay, so do we have one more question?
My name is Shaquan, and my question is, how long did it take them to build the airplane?
How long did it take to build the airplane from the kite to the airplane?
Well, they began again with the kite in 1899. They built 3 gliders to get used to flying and to develop the technology, 1900, 1901, 1902. And then they built the world's first powered airplane in 1903, and 2 more after that. This airplane was successful, but it wasn't really practical. By 1905, they had an airplane that would go up and stay as long as the pilot wanted it to and operate fully under control. So 1899, 1905.
Okay, so we have this thing sitting on our block, and we're going to guess what it is, but I want you to give us one little hint before we start the clock.
Well, when you look at the airplane, it's made out of what? Some wood, some fabric, and some metal. This is one of the metal parts of the airplane.
Okay, so let's try and guess what it is. Okay, so what do you guys think this is? Shout it out. Engine! Okay, it is part of an engine, and Tom, I think that you went to the Wright Experience and saw more. This is the crankshaft. This is part of it.
Crankcase.
Crankcase. And Tom went to the Wright Experience, and we're going to show you some inside workings of an engine.
I'm here with my friend Greg Cohn, who's the machinist here at the Wright Experience, and the best machinist I know. Greg does all of the engine work here and a good deal else. And this is a copy, really, of the engine that powered the 1903 Wright airplane, the world's first airplane. And Greg, would you tell us a little bit about it?
Be glad to. All right, like he says, this is a cutaway of their first engine for their 1903 airplane. And their idea was to make it as simply and as light as possible. They were looking for 12 horsepower, which they knew would fly the airplane. They chose aluminum, which was new on the scene at that time. And when it comes to simple construction, otherwise, they had thin sheet steel for covers. They had bicycle chain for camshaft driving. They had bicycle tubing for lightweight connecting rods. No fuel pump. It used gravity feed to supply gasoline to the engine, which was then fed to a sheet metal manifold. They used what was called automatic intake valves. The suction stroke will actually pull this valve open to admit the fuel. They used mechanically operated exhaust valves. The ignition system, also very simple, called make and break. It has a copper bus bar that is supplied with low voltage. The voltage is then enters the combustion chamber itself by a contact, and at the proper instant, the points break, creates a spark.
Well, thanks, Greg.
You're welcome, Tom. Thank you.
Okay, Tom, so you can't just have an engine. You have to have something else to propel the plane. So do you want to talk to us a little bit about what we have on the back here?
Right. The Wright airplanes were all pusher airplanes. In other words, the propeller's on the back and pushes it forward instead of being on the nose and pulling it. And the propellers, in fact, were one of the most difficult problems that the Wright brothers had to face. They look pretty simple, but in fact, they're really pretty complicated. A propeller isn't like a screw going into wood. It's a rotary wing. You drive a wing through the air and it generates lift. Well, the propellers are shaped like wings too, and as they rotate, they develop lift, just like the wing. Only instead of lift, since they're faced this way, it becomes thrust, and it moves the airplane forward.
Okay, so we've looked at a lot of things today, but there's one more question we need to answer. And to answer that question, I talked to Peter Jacob again. So Peter, we're standing here in front of the actual 1903 Wright Flyer. And during this STEM in 30, we've looked at a lot of elements. We've looked at airfoils and control surfaces and propulsion. But the thing we haven't answered, the question we haven't answered is, why the Wright brothers? Why were they successful in inventing the airplane when so many others had failed?
Well, of course, Wilbur and Orville Wright were extremely good engineers and had great ingenuity and applied those skills to solving all of these elements that you've talked about. But what really separated them from everyone else is they understood that the airplane was not one invention, but it was many inventions, all of which had to work together to have a successful flying machine. They had to have a good set of wings, a good structure, a good propulsion system, a good control system, and many other elements. So they worked on each of those things, and they knew they had to solve each of those things for the whole airplane to be successful. And today we call that a technological system, where all the components work together to achieve the successful engineering goal.
Thank you so much for answering all of our questions about the Wright brothers today.
My pleasure.
Okay, and we have another online question. And the question is, what level of math skills did the Wrights need to build airplanes?
Well, the Wright brothers had enjoyed math in school. They had algebra and they had geometry, and that was really the mathematics that they needed to do what they had to do to invent the airplane. Somebody a few minutes ago asked me how big the airplane was, and really that's something the Wrights had to figure out. They had to calculate using algebra and geometry how much wing area they were going to have to lift the weight of the airplane, the engine, and the pilot. So math was real important to the Wright brothers.
Okay, and we have another online question. Why is it important to study the origin of flight today?
Well, Rebecca, in fact, we fly today pretty much the same way the Wright brothers did in 1903. Airplanes don't look like this today, and in fact, the parts are in a different position sometimes. We use jets today instead of propellers, but the basic principles that they used of aircraft control, of studying aerodynamics and that kind of thing, that hasn't changed very much since 1903. So the basic principles were there in the beginning, and by studying those, we can understand how we got to where we are today.
Okay, and so we actually have a simulator here that's going to show us how the Wright brothers flew in their airplane. So let's go to the simulator.
Hi, it's Paul Glenshaw again, and I've got my co-pilot here. Tell us your name. Mikhail. And he and I are going to fly the Wright brothers' 1908 flyer that they brought here to Washington, D.C. To sell to the Army. And they flew it at Fort Myer just across the Potomac River. So how this works is this. We are on the ground. Now put your hand up on the control, and we're going to fly together. I'm the guy who's going to get us in the air. Here we go. We are climbing. That's the pitch that Beth was talking about. And then I put the nose down again, so you can see that this makes the airplane climb, and this makes the airplane dive. Now I'm going to get us nice and steady, and you're going to help us turn. So if you push the sticks forward, you're going to see the airplane will start turning to the left. Now pull us to the right, which means come on back. Keep going until the airplane reacts. There you go. But not too much, because then we start to go down again. So push them to the left again. And what we want to do is get the airplane to just fly nice and steady. Now we're going to see if we can land it right there on that field. This is 1908, so there's no airports anywhere. We can just land wherever we want.
So that's STEM in 30 for today. I want to thank the Alcoa Foundation, Tom Crouch, and the Wright Experience, and we hope to see you again soon.